scientists discovered a fascinating phenomenon in soap. It's not just a household item, but a complex chemical reaction that has captivated humans for centuries. When you mix soap with water, it creates a rich lather that's both mesmerizing and essential for cleaning. But have you ever wondered what exactly happens at the molecular level when soap meets water? It's a process that involves surfactants, emulsifiers, and a dash of chemistry magic. Imagine a soap molecule with a hydrophilic head and a hydrophobic tail. It's like a tiny, molecular seesaw. When soap is added to water, the hydrophilic head is attracted to the water molecules, while the hydrophobic tail repels them. This creates a dynamic equilibrium, where the soap molecules continuously move between the water and air phases. But that's not the strangest part. Soap can also clean oil-based surfaces, like greasy pans and machinery. It's like a molecular cleaning ninja, slicing through grease and grime with ease. The secret lies in the unique structure of soap molecules, which can accommodate both polar and nonpolar substances. This property makes soap an ideal cleaning agent for a wide range of surfaces and materials.
However, soap can also have a dark side. It can strip the skin of its natural oils, leading to dryness and irritation. It's a delicate balance between cleaning power and skin health, and one that requires careful consideration.
But what happens when soap is mixed with other chemicals, leading to dryness and irritation? It's a recipe for disaster, or so you might think. Creamy lather that's both luxurious and effective, and emulsifiers. The combination creates a rich, creamy lather that's both luxurious and effective. It's like a molecular dance, where the soap molecules perform a choreographed routine with the other chemicals. But that's not the only surprising aspect of soap. It can also have antibacterial and antifungal properties. It's like a molecular shield, protecting us from the invisible forces of disease and decay. The key lies in the unique structure of soap molecules, which can disrupt the membranes of bacteria and fungi. It's a fascinating example of how chemistry can be used to create new materials with specific properties. The possibilities are endless. Imagine soap-based materials that can clean, protect, and even heal our bodies. It's a world of molecular possibilities, where chemistry meets innovation and creativity. But what about the environmental impact of soap? Can it be sustainable and eco-friendly? It's a pressing concern, as soap production and disposal can harm our planet's delicate ecosystems. However, there are ways to make soap more sustainable using natural ingredients, reducing waste, and promoting recycling. It's a challenge that requires a multidisciplinary approach, combining chemistry, biology, and environmental science. The result is a cleaner, greener, and more sustainable soap that benefits both humans and the environment. It's a story of chemistry, innovation, and sustainability, one that's still being written and rewritten. As we continue to explore the world of soap and chemistry, we'll uncover new secrets and surprises. But for now, let's focus on the fascinating story of soap and its molecular magic. So the next time you use soap, remember the complex chemistry and science behind it. It's a reminder that even the simplest things can have a profound impact on our lives and the world around us. If you found this fascinating, subscribe for more incredible stories like this. And let me know in the comments what fascinates you most about soap and chemistry. Want more mind-blowing facts? Hit subscribe and join our journey of discovery. Thanks for watching. Don't forget to subscribe and engage with our community.